Supertrees with greater carbon capture may be forest climate fix. The most effective method for decreasing atmospheric concentrations of the glasshouse gas carbon dioxide, CO2, and combating climate change is probably forestation and tree growth. Supertrees, that have been genetically engineered, GM, to grow more quickly and quickly absorb CO2 may now be utilized to combat the climate catastrophe. Through photosynthesis, trees collect CO2 naturally and release oxygen as they expand, storing the gas for decades or even centuries in their trunks, branches, and roots. According to lab tests conducted by biotechnology company Living Carbon, its genetically engineered poplars capture more carbon and grow 1.5 times quicker than unmodified trees. By manipulating the DNA of the poplar using a method employed in tobacco plants, more carbon dioxide is converted into sugars during photosynthesis, increasing the amount of wood biomass produced. In order to increase growth and improve carbon storage, the Living Carbon researchers introduced genes from green algae and pumpkin. These genes slow down photorespiration, a process that consumes energy and allows fixed carbon to re-enter the environment as CO2. Biologists caution that strong growth rates are not guaranteed in the field as the poplars fight for sunlight with other plants and trees, despite the promising lab results of the company. In order to maintain their quick growth, GM trees may also require intensive irrigation and fertilization. Over the following 4 years, field tests will be conducted with Oregon State University. Results are essential in light of the speed of climate change and rising atmospheric CO2 levels. Due to trees' lengthy breeding cycles, genetic engineering can deliver effects more quickly. However, detractors claim that putting GM trees in the wild comes with risks if they cross-pollinate with other trees or have a harmful impact on other plant and animal species. According to Living Carbon, its trees are a hybrid of a poplar and an aspen that can only grow from cuttings and cannot cross-pollinate with wild trees because they do not generate pollen. Even if the field tests are a success, it will take time before the government gives its blessing. Around 135 of the U.S.'s tree species, or around 1/6, may go extinct as a result of disease, invasive insect species, deforestation, climate change, or other factors. Furthermore, despite field tests demonstrating a GM chestnut tree's resilience to an aggressive fungal disease that wiped out billions of American chestnuts, planting has not yet been authorized. Environmental organizations and scientists have long regarded supertrees as a danger to the world's forests. As large-scale commercial plantations replace old-growth forest or rainforests and are intended to serve as carbon storage offsets for polluting sectors, critics object to the impact on ecosystems while biotech corporations profit. Additionally, biomass created from plantations is burned in power plants. There are species that already meet the criteria for CO2 storage. Giant redwood trees in California may store more carbon than any other species and are resistant to disease, wildfires, and climate change. The purpose of breeding efforts to produce climate-adaptable trees that blend into local ecosystems is to replace redwoods, which are not ideal for every forestry plot. However, GM supertrees may be a part of the solution in the race to address the climate problem, enhance CO2 uptake, and boost carbon storage.